Hey folks, and welcome to Scientific Drinking. So today we're going to be talking about a topic that's pretty close to my heart. We're talking about Artemis, Gateway, and the SLS. So I know, before we get started, the SLS has been a little bit of an albatross. It's been running for years, it's billions of dollars over budget, but it's still very important to our next mission, and that's going to the moon by 2024 to put the next man and the first woman on the surface of the moon. So my job at the Kennedy Space Center primarily involves the logistics module. The logistics module is the resupply service to the Gateway. Now, the Gateway is a necessary component to permanent human presence on the moon, which is the objective of the Artemis program. Now, in case you haven't heard of Artemis, Artemis has three assets to it: the SLS, the Gateway, and the Human Landing System. Now, the SLS, as you know, is the largest launch vehicle that's ever going to launch. And hopefully it'll launch by the end of 2020 next year, but realistically, we're thinking early 2021. SLS consists of repurposed space shuttle components, along with an ascent abort stage and the Orion space capsule, which is also going to be this guy up here, capable of going to the moon and re-entering Earth's atmosphere. Now, the Orion's different from other capsules offered by SpaceX and Boeing, for example, the Starliner and Dragon capsule, because it's capable of re-entering the Earth from much higher speeds, such as speeds you'd expect coming from Mars or from the moon. Whereas the Dragon and Boeing Starliner can really only handle the heating experience when coming back from something like low Earth orbit. Now, a second critical component is the Gateway. Now, a lot of people have asked, both within NASA and outside, of why the Gateway is important. Now, there's a lot of important reasons to have the Gateway. If you just wanted to land on the moon by 2024 and get home, check that off the box. We've done that already. That was Apollo. You can get that done without the Gateway. Now, important part of the Gateway is ensuring 4 parts, what I call PACE. P stands for partnerships. We want to be ensured that both commercial and international partnerships can help involve themselves in the lunar expedition. Not just the first 2024 expedition, but continued presence on the moon. So the Gateway offers them a waypoint to reach this lunar outpost and gain access to the surface without needing a really big rocket like the SLS. Now, the SLS is really important to delivering really heavy payloads up into lunar orbit, mainly Orion. Orion itself is a pretty big spacecraft, a lot bigger than Apollo. That being said, individual components of the Gateway, such as the power propulsion element, the halo, which is the minimum habitability element, which is put in place to help achieve our goal by 2024, along with the elements of the Human Landing System, the ascent, descent, and transfer elements, can all be delivered by commercial payloads, which is part of NASA's effort to involve the commercial partnerships and develop a robust commercial space industry. Now, the second element of PACE is A, accessibility. Now, the Gateway allows access to the entire surface of the moon, which is something that you can't get from a usual low lunar orbit. All of the Apollo missions landed around the equatorial band of the moon, because that was the easiest to get to with a low lunar direct inject trajectory. But with Gateway, it's put into something called the NRHO, or Near Rectilinear Halo Orbit, which is illustrated here. Now, this allows access to not only the equatorial region of the moon, but also the poles. From the L-CROSS and LRO missions, we know that there's a lot of water ice on at least the south pole of the moon. Now, water ice by itself is valuable for making water, as you might guess, but through electrolysis, you can break that up into hydrogen and oxygen, which is rocket fuel. Oxygen is also air. So there's a lot of reasons to access that water ice on the south pole of the moon, and the NRHO enables that. So in addition to the partnerships the NRHO and the Gateway enable, it also allows the access to the water ice hidden in the lunar poles. Now, I'll get back to the NRHO in a little bit. So the third element to PACE is sustainability, S. The goal, like I said, of the 2024 mission isn't just to put boots on the moon, but it's to keep them there. We want to build a lunar outpost. We want to make sure that the moon can be utilized as a resource for commercialization and industrialization for long into the future and enable deeper space missions into Mars and beyond. So in that vein, one of the goals of the Artemis program is to build up a lot of infrastructure on the moon to help enable harvesting this lunar ice, to see what it really takes to take this ice out of the soil and to get it up into this outpost called Gateway. And then we can have a refueling depot in orbit around the moon so that we can go to Mars and beyond. The last element of PACE is E, exploration. Naturally, Mars and beyond, right? Our biggest goal here at NASA and beyond is to get to Mars. I mean, that's Elon Musk's dream, that's our dream. We've been talking about that for decades. All the components that make up Gateway are the same components that can be used to build up a Mars vehicle. So the power and propulsion element, the habitation elements, the logistics modules, everything that goes to the Gateway can be repurposed for a Mars mission. We can assemble this in low Earth orbit and send it on its way. So really what we're doing on the moon isn't just building a lunar outpost, which by itself is pretty cool in my opinion. We're enabling deeper space exploration by building this outpost. So that's why Gateway itself is important. Now, I said before I'd come back to the NRHO. NRHO was the result of a case study, looking at several different options in several different orbits. It's kind of non-intuitive when you look at it. It's kind of a weird potato chip shaped orbit. And it's not something you'd think immediately like, oh, let's go to the moon, let's put it in NRHO. But there are hidden benefits to the NRHO that might not be immediately apparent. First, I mentioned partnerships. The NRHO allows us to get these partnerships off the ground. Many of the rockets that are available from commercial and international partnerships, such as the H-2B from Japan or the Falcon Heavy from SpaceX, all these can reach the NRHO given a moderately sized payload. Now, they couldn't put a man on the moon, but they can get it to NRHO. So by enabling this commercial partnership, and people can reach Gateway and then put something on the moon one step at a time. Now, the second part is lunar accessibility. As I mentioned before, the accessibility of the NRHO and Gateway is important by itself, but the NRHO is specifically designed to allow global lunar access, which is something that can't be provided from other options, such as a frozen orbit or a low lunar orbit. Thirsty. Another good point about the NRHO is station keeping. You only need a few meters per second delta V per orbit to keep it in place. Granted, you have things like lunar frozen orbits that are really cheap, but frozen lunar orbits don't allow accessibility to the moon or from Earth very easily. They're more expensive in terms of delta V. In this animation, you can see the NRHO in 3 frames of reference. The first is the Earth inertial frame. So think of this as if you're moving with the Earth in its orbit around the Sun, this is what the NRHO would look like as it orbits the moon. The second frame of reference is the Earth-Moon rotating frame. So this would be as if you're moving with the moon, looking towards the Earth all the time. And so this is where the halo aspect of the orbit becomes apparent. Now you can see it orbiting 7,000 kilometers at closest approach towards the North Pole and 40,000 kilometers away in the southernmost, what we call the apollune. Now the third frame is the moon inertial frame. This is as if you were moving with the moon in its orbit around Earth, but looking at a fixed point in space. From this, you can see that you have global surface access to the surface of the moon. Now, another big point about the NRHO is its efficiency. This isn't something I included in the PACE acronym, but it's still equally as important. For unmanned payloads, such as resupply missions or adding components onto the Gateway, you can use what's called a ballistic lunar trajectory, which means you have this flyby of the moon, you go past the moon into what's almost heliocentric orbit, but then you come back and you're just kind of naturally inserted into the NRHO. For almost no cost. We're talking about tens of meters per second, as opposed to the burn you'd have to do otherwise if you're doing a fast transfer of hundreds of meters per second. So this is a really big advantage to the NRHO. You can drop supplies in there for very low cost, relatively speaking. It also allows a wide range of launch times and options. You can get there in a couple months or as long as 5 months, depending on when you launch and what your goals are. So the final point I wanted to address was the human landing system. This is a little bit different than the Apollo mission. But during the Apollo mission, we had a really big rocket, the Saturn V, with the Apollo lander and the command module, along with the Apollo capsule, all in one unit attached to the top of the rocket. And it was a one-shot, land on the moon, back up, back to Earth mission. Here, we're doing things a little bit differently. We have what's called the human landing system, which is 3 components: the ascent module, the descent module, and the transfer element. All of these can be launched by existing commercial launch systems, which means we don't have to design a specific system to accommodate this. Furthermore, one of the benefits of the human landing system is that sustainability I mentioned before about Gateway. That ascent module, which can be seen here, is reused time and time again. So you don't have to send up a specific rocket for that ascent module. Now we're still disposing of the transfer element and landing the descent elements on the surface, accumulating them for future use. So it's not completely reusable, but far more reusable than Apollo was. So I hope that clears up some things with the Artemis mission. Thanks for watching. Hey, if you like videos like this and want to keep watching in the future, next episode is going to be about black holes, so stay tuned. Cheers, guys.